Good day, everyone. Welcome in physical science. Today, our topic is limiting reagents. Now, what is limiting reagent? If the amount of the two reactants are not stoichiometric amounts, one of the reactants will be used up first, and this reactant is called limiting reactants or limiting reagents. Some of the other reactants remains unreacted when the reaction has completed. So this reactant is called excess reactant or excess reagents. So we have two methods in determining the limiting reactants. First method is we convert first the given amounts of the reactants into moles. Then we divide the actual number of moles of the reactants by their respective coefficients in the balance equation. The one that gives lesser value is the limiting reactants. In the second method, we get the stoichiometric amount of a certain product from each of the given amounts of the reactant. So we have a sample here, aluminum plus hydrogen chloride and aluminum chloride plus hydrogen gas. So if 10 grams of aluminum and 5 grams of hydrogen chloride are initially present. So find A, the limiting reactant, B, the excess reactant, C, the mass of the excess reactant that will be consumed in the reaction, D, the mass of the excess reactant that will remain unreacted, E, the mass of aluminum chloride that will form, and letter F, the mass of hydrogen gas that will produce. So first, what we're going to do is to balance the equations. So we have here, okay, we're going to put a coefficient 2 here. We have 6, 2, and 3. So let's check. So aluminum here for the reactants is 2, and aluminum here is 2 for the products. We have hydrogen 6 for the reactants. We have hydrogen 2 times 3 is 6 for the products. And we have chlorine 6 for the reactants. And we have here 3 times 2 for the chlorine for the products. So it's equal. Now, first, what we're going to do is to get the molar mass of aluminum and the molar mass of hydrogen chloride. So here, the molar mass of aluminum, so we are going to do is to get the value of the molar mass in the periodic table. So the molar mass of aluminum, the periodic table is 27 grams per mole. And for the hydrogen, 1, and for the chlorine is 35. So 35 plus 1, that would be 36. Okay, 36 grams per mole. The first method is, so we have here the number of moles of aluminum. So that would be 10 grams, is given, over 27 grams of aluminum. So 10 divide 27, the answer is 0.350 moles. So cancel the grams, cancel the grams. Another one is the number of moles of hydrogen chloride. So we have here 5 grams of hydrogen chloride in the given problem over 36 grams per mole. So we have here. Therefore, 5 divide 36, that's a 0.139 mole. Cancel the grams, cancel the grams. Next, for aluminum, so we have 0.370. Okay, we have mole over 2. We have coefficient, so therefore 0.185. So 2 here, okay. Coefficient 2 came here. Next, for hydrogen chloride, 0.139. So this one over 6. So here, therefore, the answer is 0.023. Now, hydrogen chloride is the limiting reactant since it gives the lesser value. So here, 0.023 and 0.185. So the lesser value is hydrogen chloride when the numbers of moles are divided by the coefficients. So limiting reactants in this sample problem is hydrochloride. The second method is consider the product of aluminum chloride as our basis. So we have here, based on aluminum, the mole of aluminum chloride is equal to 10 grams of aluminum, then 1 mole of aluminum over 27 grams of aluminum. So this is the molar mass of aluminum. Then we have 2 mole of aluminum chloride, so here, and 2 mole of aluminum, okay, here. This is the came from the coefficients of the equations. Therefore, you have 10 times 1 over 27, or divide 27 times 2 divide 2, the answer would be a 0.370 mole. So cancel, 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 cancel. The remaining is mole of aluminum chloride. So the mole of aluminum chloride is 0.370 mole. Now, based on the hydrochloric acid, so mole of hydrochloric acid is equals to 5 grams of hydrochloric acid times 1 mole of hydrogen chloride over 36 grams of hydrogen chloride. So this is the molar mass of hydrogen chloride times 2 mole of aluminum chloride. So this 1 over 6 moles of hydrogen chloride. So this 1. So therefore, 5 times 1 of divide 36 times 2 divide 6. So the mole of hydrogen chloride is 0.046 mole, which is lesser. Therefore, based on this calculation, okay, the limiting reactants is hydrogen chloride. Now for letter B, the answer is excess reactant is aluminum. Of course, the limiting reactants is hydrogen chloride, so the other one is aluminum, which is considered as excess reactant. Flower C, mass of aluminum that will be consumed. So here, this is given. So 5 grams of aluminum chloride. So that would be 1 mole of, okay, um, hydrogen chloride over 36 grams of hydrogen chloride. Okay, times 2 mole of aluminum over 6 mole of hydrogen chloride. So this is came from the coefficient times 27 grams of aluminum. So this is the molar mass of aluminum over 1 mole of aluminum. So therefore, in the 27 grams of aluminum, there is 1 mole of aluminum. So cancel, 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 cancel. So the remaining unit is, okay, grams of aluminum. So therefore, we have 5 times 1 divide 36 times 2 divide 6 times 27 divide 1. So therefore, the answer 1 is 1.25 grams of aluminum. For letter D, so mass of unreacted aluminum. So what we are going to do is 10 grams, which is the given, minus 1.25 here is equal to 8.75 grams. So the mass of unreacted aluminum is 8.75 grams. Now for letter E, the mass of aluminum chloride. So we have 5 grams of hydrogen chloride times 1 mole of hydrogen chloride over 36 grams of hydrogen chloride times 1 mole of aluminum chloride over 6 mole of hydrogen chloride. So which is get from the coefficient times 132 grams of aluminum chloride. So this is the molar mass of aluminum chloride. So over 1 mole of aluminum chloride. So the answer would be is 6.11 grams of aluminum chloride. So cancel, 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 cancel. So the remaining unit is this one. So it's a grams of aluminum chloride. Next, for letter F, we have the mass of hydrogen gas. So we have 5 grams of hydrogen chloride times 1 mole of hydrogen chloride over 36 grams of hydrogen chloride. So this is the molar mass of hydrogen chloride times 3 mole of hydrogen. So this came from the coefficient of hydrogen over 6 mole of hydrogen chloride, which also came from the coefficient of the equation. So times 2 grams of hydrogen gas. So we have the molar mass of hydrogen is 1 times 2. Therefore, we have 2 grams over 1 mole of hydrogen grams. Therefore, the answer is 0.139 grams. So cancel, 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 cancel. So the remaining unit is this. The answer would be 0.139 grams of hydrogen gas. Next, percent yield. So in a chemical reaction, the theoretical yield is the stoichiometric amount of a certain product based on the amount of limiting reactant. So the actual yield, so the amount of this product recovered after the reaction, is always less than the theoretical yield because some of the particles of this product are left unrecovered from the reaction vessel. So the percent yield is the percent of theoretical yield recovered after the reaction, and it's given by the formula. So percent yield is equals to the actual yield over or divide theoretical yield times 100%. Now let's do this. For example, in a reaction vessel, 15 grams of nitrogen gas and 4 grams of hydrogen gas were allowed to react to form ammonia. So A, what is the theoretical yield? B, percent yield. So first for letter A, so nitrogen gas, what we're going to do is to have an equation of the given problem. So nitrogen gas plus 3 moles of hydrogen gas, then reacts with 2 ammonia. Okay, so we have here first, we have number of moles of nitrogen gas is equals to, okay, so 15 grams in this given problem over 28 grams of moles. So this is the molar mass of nitrogen gas. So therefore, the answer would be 0.536 mole. Another one's number of moles of hydrogen gas. So therefore, we have here 4 grams in the given over 2 grams per mole. So this is the molar mass of hydrogen gas. So we have 1 plus 1 equals 2. 4 divided 2, that would be 2 moles. So cancel the grams, cancel the grams. Next, for nitrogen gas, so what we're going to do is to copy this one, number of moles, 0.536 mole over 1. Okay, this is for the coefficient. Okay, the this one, so therefore 0.536 over 1, the answer is 0.536. Okay, so this is lesser for the hydrogen gas, which is the value is 2. This one, 2 mole over 3, so this one is 3 coefficient. 2 over 3 is 0.67, so therefore this is the lesser value. Now the limiting reactant in the said given problem is nitrogen gas, and the excess is hydrogen gas. Now for the theoretical yield, so we have 15 grams of nitrogen gas, so therefore 1 mole of nitrogen gas over 28 grams of nitrogen gas, which is the molar mass, times 2 moles of ammonia, so this one, over 1 mole of nitrogen gas, times 17 grams of ammonia. So this is the molar mass over 1 mole of ammonia. So therefore, we have 18.2 grams of ammonia canceled out, canceled out, canceled out, canceled out, canceled out, canceled out. So the main unit is grams of ammonia. So the answer is 18.2 for the theoretical yield. However, for letter B, what we're going to do is to get the percent yield. So the actual yield over theoretical yield. So the actual yield is 16 grams over 18.2 grams times 100%. So the percent yield is 87.9%. Now for your additional activity or for your assignment, so what you're going to do is to balance the equation and answer the following. So we have A, B, C, D, E, F. So we have here. And for another assignment, balance the following equations. So we have letter A and letter B. After that, okay, what you are going to do is to submit your assignment on this link. Now for our assessment, so direction, choose the letter of the best answer and write it on an extra sheet. So number one, it is the reactant that produces a lesser amount of product. A, excess reactant. B, percent yield. C, limiting reactant. D, cofactor. Number two, which of the following describes relationships of the number of moles and mass of the reactant and products in a chemical reaction? A, molality. B, stoichiometry. C, balancing equation. D, percent yield. 3. It is the maximum amount of the product you would expect from a reaction based on the amount of limiting reagent. A, theoretical yield. B, limiting reactant. C, excess reactant. D, product difference. We have 4. This refers to the reactants which were not used up after completion of the chemical reaction. A, excess reagents. B, limiting reagents. B, or C, solute. D, solution. 5. It is the process that involves rearrangement of the molecular ionic structure of a substance to form a new substance or product. A, chemical equilibrium. B, chemical reaction. C, chemical symbols. D, stoichiometry. 6. What is expected value for percent yield? A, negative 1. B, 0 to 100. C, above 100. D, 95 to 100. 7. Which of the following equation below is balanced? A, there's 1. B, C, D. Number 8. In the equation of magnesium plus hydrogen chloride reacts with magnesium chloride plus hydrogen gas, how many molecules of hydrogen do we need to make hydrogen balance? A, 3. B, 6. C, 2. D, 7. 9 to 11. How many moles of chlorine gas can be produced if 4 moles of iron chloride react with 4 moles of oxygen gas? So this is the equation. What is the limiting reactant? And what is the excess reactant? For our answer, the answer is number 1, C, 2B, 3A, 4A, 5B, 6B, 7D, 8C, 9, 6 moles of chlorine gas. Then we have iron chloride, and layer number 11 is oxygen gas. So that's it for today. Have a good day, everyone.